Greetings to all the viewers. Here, the session is going to cover with the compound called quinoline. Quinoline is designated as a benzofused pyridine in accordance with the IUPAC nomenclature. The preferred IUPAC name for this is mentioned as quinoline itself. IUPAC stands for International Union for Pure and Applied Chemistry. The session is powered by AI. Artificial intelligence powered the session is going to be conducted. And here is the 3D representation is provided where ball and stick model is represented. All the black color lobes indicated for the carbon atoms and ash color lobes indicated for the hydrogens. And here is the nitrogen taken as the hetero atom, which is indicated by the blue color lobe. And this is the way our representation for benzofused pyridine is provided, and it is the kind of heterocyclic compound, fused heterocyclic compound. In specific, six-membered bicyclic fused heterocyclic ring system that is called quinoline moiety, right? The quinoline is also provided over here where all the atoms are existing in a cyclic system and the conjugated system is provided. Nitrogen is taken as the heteroatom within this quinoline molecule, right? Let me give the agenda of the session. Here, the topics to be discussed are introduction to the session and the synthetic strategy, how can we synthesize and what could be the properties of this quinoline, and chemical reactivity towards various kind of reagents, and what could be the applications for this quinoline molecule. These are the topics to be discussed in the session. A brief intro regarding the quinoline is provided here. Quinoline is a heterocyclic aromatic ring system and consisting benzene ring fused with the pyridine ring. It is the fused one. One is the benzene, another is said to be pyridine. Both are going to be joined together by this fused process, right? Here are 9 carbon atoms and 7 hydrogens and 1 nitrogen taken into the consideration as the molecular formula. It is composed by 9 carbons, 7 hydrogens and 1 nitrogen heteroatom, right? And nature is indicated as weakly basic, being a nitrogen lone pair of electrons taken outside of the ring. They are excluded from the ring aromaticity, and these electrons will take for its basic nature, and that may proceed for that reaction with any kind of acid. So it is said to be weakly basic due to the existence of lone pair of electrons upon the nitrogen indicated for the Lewis basicity. And bicyclic structure where the benzene and pyridine ring are fused together, and here is the bondless representation provided. All the atoms are got fused, and ash color lobes indicated for the hydrogens, black color for the carbon, and heteroatom nitrogen. Most important pharmacophore in case of the compound is said to be heteroatom, and that is nitrogen indicated with the blue in color. And here is the resonance hybrid represented in the three-dimensional form where all the pi electrons having the provision to rotate. The rotation is indicated by this circle where all the electrons non-static and moving among all the atoms, so that they are distributing pi electron density among all the atoms within the ring equally, right? And significance of the quinoline, why we are going to study about this compound, what importance it possesses, that is said to be significance, right? Quinoline is a kind of natural alkaloid. Alkaloids are nothing but organic compounds essentially containing nitrogen as the important moiety over there. That is the essentiality for the alkaloid quinoline. So many quinoline alkaloids are observed in the nature. Here is the most important compound is called cinchonine, and here this casparin. Casparin is another compound, and here is the most important motif called the quinine. So the compounds whichever manifested here all are regarded as alkaloids only, and all are composed by nitrogen heteroatom. And quinoline based alkaloids, nitrogen is the essentiality over there, and they are found in the plants, and quinolone ring is the most common existence over this kind of alkaloid systems. And here you can notice cinchonine is the cinchona plant will be there. From that you are able to extract this cinchonine alkaloid, and from which we are able to extract this quinine. Quinine is most potential anti-malarial agent, and here is the compound called the casparin. Casparin is also quinoline moiety, and it is in contact with the benzene fused with the oxygen heteroatom fused ring system will be there, and here is the methoxy linkage. This is the way quinoline based alkaloids are provided within the slide. And this is the most important categorization regarding that pharmacological potency of these quinoline-based alkaloids. You can quinoline-based for pharmacophores you can clearly observe, and all the molecules whichever manifested in the slide are already established proven marketed drugs, right? So which are having potential applications in our day-to-day life, which are already used as medication. Right, ciprofloxacin, most of the people are aware about this one. It is the kind of antibiotic which is made by this quinoline, where in propylation, cyclopropyl moiety is located on the nitrogen, and here is the kind of two nitrogens containing six-member ring system, and here is the fluoro functionality, and carboxylic acid is located at the position number 3, and ketonic functionality over the position number 4. This is the molecule is represented as a ciprofloxacin, which is the effective antibacterial agent. And we are having sparfloxacin. Sparfloxacin means for what? A kind of quinoxylone moiety again present here. Fluorofunctionality is amplified. One more fluoro group is accorded at the position number 8. And here is the two nitrogens containing six-member heterocyclic ring system, and two methyl groups are located. This is the kind of slight structural reformation, or else upliftment of this ciprofloxacin itself, and this is a kind of sparfloxacin. It is the kind of derivative from the ciprofloxacin only, and again it is possessing antibacterial, being more number of fluorinated groups are located upon the molecule, so that this is to be amplified activity. This is expected to be amplified activity. Ofloxacin is also known for most of the people antibiotic it will be, and most familiar antibiotic used in day-to-day life, and again it is composed by this kind of quinoline with this carboxylic acid at position 3 and the ketone at the position number 4, fluorofunctionality at this position 5, 6th position, and 7th position is having heterocyclic ring system, and this 8th position is given with alkyl chain. So this is again possessing antibacterial activity. Norfloxacin is also a kind of bacterial infection reducing agent that is mostly used for the infections caused by bacteria and even virus. So many kind of different kind of diseases get curated by norfloxacin. It is composed by again quinoline molecule, and here gatifloxacin is another molecule that all the skeletons whichever manifested in the single one are said to be a kind of structural resembling molecules having slight structural modification only. That is said to be what? All are said to be derivatives only. These are the trade marketed antibiotic compounds having almost similar resemblance in their quinoline core, and a slight existence of chemical transformations you can observe, and all are said to be antibacterial agents only, right? And individual representation is provided. Ciprofloxacin is the kind of effective antibiotic. Most widely applied one here, it is made by this fluoroquinoline, and it is named as a fluoroquinoline. Antibiotic drug, it will be treating different type of bacterial infection, especially in the case of cough and cold, long-standing cough and cold effectively curated by means of the ciprofloxacin. Let me go with the ofloxacin. Ofloxacin is also the kind of antibiotic. Again, you can clearly observe where we are having a ring system. One more ring system is located. In addition to the systems, whatever present in the ciprofloxacin, slight increase in the annihilation you can observe, and it is more effective for this pneumonia. Urinary tract infections get effectively curated. Kidney related problems, infections get curated. Gastrointestinal tract, digestive system, if any infection attacked, there also we are effectively working this ofloxacin. And skin, soft tissue damage or infection, and the lung pneumonia. Pneumonia is a kind of symptom which is observed in most of the people, those who are suffering with the immunity deficiency, and that may induce a kind of infection caused by this kind of microorganisms, and which effectively curated by fluoxetine. right? So pneumonia is an inflammation and fluid in lungs caused by the bacterial, viral, or fungal infection. Any of the pathogen able to induce such kind of pneumonia, and that able to increase the size of that lungs, and fluid may enter into that one that used to destroy the activity, healthy health of that lungs. Norfloxacin is again most potential antibiotic we are able to use for the bacterial infections and urinary tract infections. If people suffering with gastrointestinal tract issues will be effectively curated by this one, and here tonsils, sinus, nose, throat, skin infections effectively curated by this drug called norfloxacin, and the people who are suffering with continuous vomiting and motions at that condition also, that may caused by the bacterial infection only, that also effectively curated by this norfloxacin antibiotic agent. And here we are having the most familiar, important kind of antibiotic called quinine, anti-malarial drug. It will be malaria is a kind of mosquito-induced, mosquito-mediated disease. It will be so that kind of disease effectively, fever effectively curated by means of the drug called quinine. Quinine is composed by this quinoline, and here we are having piperidine ring, and it is bridged with this side chains as well. This is the way quinine is also extracted from the cinchona bark, and that is effective anti-malarial agent. By that, significant applications of the quinoline got discussed in detail. Hopefully, it is observed that the compound is worthwhile to go for the consideration and exploration as well, right? Let me go for the synthesis of quinoline fast. Here, so many methods are available. Scrap synthesis is the most important and first introduced method of quinoline synthesis. Aniline, glycerol, sulfuric acid, and oxidizing agent like nitrobenzene together are working in order to originate this quinoline as the final product. The starting material will be aniline and to be treated with glycerol in the presence of sulfuric acid and nitrobenzene working like a catalyst, giving rise to quinoline as the final product. Aniline is taken as the benzene having NH2, and here glycerol is a trihydroxy compound. Nitrobenzene is taken as a solvent media upon the arrow, and that able to give the high yield of this quinoline as the final product, right? In order to achieve this scrap synthesis, there are multiple steps involved in order to accomplish the reactant into the product. So that glycerol was taken and to be treated with the dehydrating agent sulfuric acid. Upon dehydrogenation reaction, that able to generate acrolein formation is possible. This able to remove the water, dehydration is accomplished, and here also two adjacent hydroxyl will lose water molecules, subsequently giving rise to aldehyde functional group over there. And here the origination of the olefinic double bond here is about the aldehydic one, which is called acrolein, and that to be treated with dehydrated compound. This glycerol to be dehydrated by means of sulfuric acid, which is the effective dehydrating agent, and that generated alpha beta unsaturated aldehyde to be treated with aniline. Aniline is supposed to react at the olefinic carbon atom terminal, and that able to migrate the bond towards another side, and pi bond is shifted towards the oxygen atom, so that here an alkylation is accomplished. Whenever an alkylation is carried, there will be a synchronous form, and we are having enol form will be generated. Enol obviously go for the tautomedism, giving rise to a ketonic form. Here is the terminal aldehyde will be originated. Whatever aldehyde we have, that is more effective for the ring cyclization with this benzene, which is in adjacent position, so that ring cyclization is accomplished, so that ketone will transform into alcoholic functionality upon the acidified conditions, so that whenever this bond is moving, there is origination of carbocation and ring destroyment of that ring aromaticity, which is highly unfavorable. Immediately it will go for the deprotonation, and restoring the benzenoid nucleus is possible later. The molecule is said to be dehydrated by means of the sulfuric acid catalyst at the position number 3 and 4, so that there is existence of a double bond. Alkene will be generated over there. Olefinic double bond will be originated by means of this dehydration process later on. We have to go for the oxidation. Oxidizing agent will be nitrobenzene. Nitrobenzene not working like a solvent, rather it will be the catalyst working like a oxidizing agent. Whenever oxidation is accomplished, so that another nitrogen to carbon double bond is also generated, that giving rise to entire quinoline skeleton, so that unsubstituted quinoline is obtained as a final product by means of the scrap synthesis process. In order to accomplish this reaction, we are supposed to bind up aniline, glycerol, and sulfuric acid nitrobenzene in a stoichiometric ratio, giving rise to expected product quinoline with the high yield. Let me go for another named reaction, Pyridine-Heterocyclic synthesis for quinoline. And in order to synthesize quinoline by means of Pyridine-Heterocyclic synthesis process, orthoamino-benzaldehyde to be taken and added with this acetaldehyde. Acetaldehyde is the reagent added upon this orthoamino-benzaldehyde. Sodium hydroxide is working like a base catalyst, and ethanol is the solvent media. They are condensing together, condensation giving rise to water as the byproduct, giving rise to skiff base. Whenever amine and aldehyde combined, condensation between the amine and aldehyde is said to be skiff base, and that giving rise to imine linkage called a skiff base. The skiff base further accorded for the ring closure reaction, annulation process will be accorded among this aldehyde and this olefinic imine linkage, so that giving rise to final product quinoline by dehydration process. This is the way Friedlander synthesis will be accomplished. There will be sequential mechanism is given for this Friedlander synthesis. For that purpose, we are having initially that ketonic functionality that may be transformed into enolic form by means of tautomerism. Enol will react with this what we can say alpha amino benzaldehyde. It will be anthranaldehyde. If we are having carboxylic acid over the position R, though, that is said to be antranilic acid, right? But here we are having aldehyde, so that it is said to be antranaldehyde. So this aldehydic functionality will react with this olefinic double bond, so that there will be existence of new carbon-carbon linkage, and here the formation of R1, R2 existing on the carbon atom, and here this is supposed to be converted into a ketonic functional group. And here, whenever bond is moving towards the oxygen, get hydroxy functional group over this carbon atom, and the amino functional group, whichever located upon the benzene ring, will proceed for the ring cyclization by contributing their lone pair of electrons for the bond formation among the nitrogen to carbonylic carbon atom, so that ring cyclization is accorded and hydroxyl functionality is generated at the position number 2, and these are supposed to go for the dehydration in between the 1 and 2 positions. Subsequently, there will be origination of double bond, and moreover, another fourth carbon is also accompanied by this hydroxyl, so or subsequent dehydration one more time, giving rise to disubstituted quinoline as the final product by means of Friedlander synthesis of quinoline. Let me go for Dobner-von Miller synthesis. Dobner-von Miller synthesis is accompanied by aniline as a starting material, aldehyde to be taken, and this is said to be pyruvic acid. Pyruvic acid is supposed to be treated with this aniline, giving rise to this quinoline as the final product. In order to accomplish this reaction, there are multiple stages, multiple steps involved in the reaction, so that final product quinoline will be originated. In order to get that one, aniline is supposed to be reacted with the pyruvic acid, that is alpha beta unsaturated. Aldehydic compound lone pair of electrons are supposed to bind over this olefinic double bonded carbon atom, and the pi bond is moving towards the carbon atom, and this pi bond is moving toward the oxygen, and that will be protonated, so that here the allocation of the nitrogen to carbon new bond formation, and that will proceed for the deprotonation, and this enolic form will be further go for the bonding with this proton, and so that these electrons are moving over there, giving rise to double bond. So their existence of aldehydic linkage is possible, and that will participate in the ring cyclization and subsequent restoration of the benzenoid nucleus. And whenever benzenoid nucleus is retained further, that will go for that oxidation, giving rise to final product quinoline. This is the way This is the way a Dobner-von-Miller synthesis is accomplished between this aniline and this pyruvic acid, giving rise to quinoline as the final product. By that, we successfully accomplished the various methods of the synthesis for the quinoline manufacture in the laboratory viable methods, and even the even in the industrial scale manufacturing, bulk drug manufacturing is also possible. Let me discuss about the physical properties of this quinoline molecule. So what are the important physical properties of the quinoline to be discussed? Physical properties appear in it appears like a colorless or pale yellow in color liquid it will be. So yellow color liquid clearly absorbed in this small cuvette, and boils at the temperature of 238 degrees centigrade, so that we can conclude this liquid is a non-volatile in nature, and melting point is accorded as -15 degrees, so that at room temperature conveniently liquid itself. Solubility will be more in water, and organic solvents able to dissolve this one, like alcohol, ether, and benzene as well, right? So water solubility is extremely less. That is because of that compound is having higher the content of the carbon. More the carbon content, more will be the solubility towards the organic solvents, as in a obvious manner. That's the reason why organic solvents are preferable to dissolve this quinoline in comparison to the water. Being it is made by this pyridine nucleus, so that pyridine resembling order will be given, that is a characteristic pyridine order will be accompanied by this quinoline molecule. And let me discuss about the chemical properties of that quinoline. Quinoline is basic in nature, being pyridine like resemblance. Pyridine skeleton is accorded within the molecule. That's the reason why, like pyridine, it is also basic, but in comparison to pyridine, its value is somewhat lesser. 4.9 pK value is indicated for the quinoline, and where pyridinium ion is having 5.2, that is somewhat larger. That indicates in comparison to the pyridine, the basicity of this quinoline is slightly lesser in nature, right? So lesser basic in comparison to the pyridine, right? So the lone pair of electrons and the nitrogen are responsible for the donation, but the adjacent benzene ring is also participating in the kind of minus inductive effect. That's the reason why slight lowering or decrease in this basicity is observed for this quinoline molecule. Let me introduce this resonance for this quinoline. Quinoline is participating in this delocalization of the pi electron in such a manner, giving rise to various charge separation within the molecule due to the various canonical structures. Much more pi electron delocalization is possible over there. That's the reason why there is pi electron delocalization, giving rise to positive charge over the carbon number 2, carbon number 4, carbon number 5, carbon number this is a fused carbon is accorded. The carbon number 7 is also accorded with this positive charge. That's the reason why this is obviously go for the resonance, and many canonical structures observed, obviously it is go for the high stability. Later, we will discuss about the aromaticity of the compound, all the carbons and nitrogen together participating in sp2 hybridization, and moreover, pi electron cloud is generated by the lateral overlapping of the bonds, and all are laying in the single plane because of the sp2 hybridization, and they are perfectly obeying the Huckel rule, that is 4n plus 2 pi electron system is existing within the molecule, and the molecule is accorded with a 6 plus 2, 8 plus 2, 10 pi electron system. 10 pi electron system, 4n plus 2 n value is calculated as 2. That indicates it is the integer value that is indicated for this aromaticity, and it is the cyclic system. There is a plenarity, there is a sp2 hybridization, there is a conjugation, there is a restriction towards the addition reaction, there is the stability exceptionally, there is the characteristic electrophilic substitution. All these are confirming the molecule is said to be perfectly aromatic in nature in accordance with their resonance structures and multiple probabilities for the satisfying this aromaticity. Moreover, Huckel rule is perfectly obeyed by this compound. And the basicity of this quinoline is perfectly evidenced by adding this hydrochloric acid. Hydrochloric acid is binding with this pyridine, so that pyridinium chloride, that means a quinolinium chloride salt formation is possible. This indicating the weak basicity of this is proving weak basicity of this quinoline molecule. At the same time, this AlCl3 acidic medium is able to give the complexation between this Friedel-Crafts reagent with this nitrogen atom, so that again there is a quaternization we can clearly observe, and moreover it is go for N substitution. N acylation is also possible, giving rise to again quaternized quinolinium. N-acylated quinoline formation is possible. This is the way multiple reactions which are evidencing that there is a basic nature accorded for the nitrogen due to the free donation of the lone pair of electrons, being they are not taking part of this aromatic ring system, and they are free for this protonation or any reaction with the acids. Now we are going to discuss about the electrophilic substitution reactions pertaining to this quinoline molecule. They are the feasibility for this electrophilic substitution over the positions of 5th and 8th are most familiar for this quinoline, being these positions giving rise to more stable resonating structures when the electrophile is going to be substituted at the 5th and 8th positions respectively. And this is the way numbering is accorded for the system. Obviously, heteroatom is accorded with the number 1 and 2, 3, 4. 5th, 6th, 7th, 8th, and the bridge head carbons are indicated with 4A and 8A respectively. Electrophilic substitutions are having provisions, various provisions are possible, either 2nd, 3rd, 4th, 5th, 6th, 7th, 8th. These many positions, though available, there is a competing factor between this pyridine ring and benzene ring, where to substitute. Pyridine ring, benzene ring are fighting together where to substitute this electrophile. In order to avoid that ambiguity, being both are having 6-member ring systems only, and 6 pi electrons and 6 atoms are contributing for that 6 pi electrons. But the factor which is deciding for this electrophilic substitution on the benzene rather than this pyridine will be electronegativity of the nitrogen. Electronegativity of the nitrogen is destroying the electron density by certain extent in comparison to the benzene ring. That's the reason why pyridine ring will be electron deficient in nature, and more preferably electrophile will go for the substitution over the benzene ring. So that we clarified the ambiguity where to substitute the electrophile, whether pyridine or benzene. And upon the benzene ring, again we are having 4 probable sites. One is position number 5, 6, 7, 8. Among 5, 6, 7, 8, only preferential position 5 and 8 go for this electrophilic substitutions more comfortably, and giving rise to 5 and 8 substituted products as well. That is the reason, because whenever electrophile is supposed to be attached at the position number 5, generating the carbocation over the position 6, that better stabilized by more number of canonical structures. At the same manner, whenever electrophile is attaching at the position number 8, again the carbocation generated will be well stabilized. But whenever 6th and 7th positions are substituted, the carbocation will be static, that will be less stable. This is the reason why electrophilic substitutions are more familiar and convenient at the position number 5 and 8 on the quinoline, because of the more stabilized resonance structures. Let me perform the nitration of the quinoline. Nitration is supposed to be carried on the quinoline by adding the concentrated nitric acid and sulfuric acid mixture at the temperature of 0 degrees centigrade, so that there are 2 probabilities, 51% of 5-nitroquinoline, 49% of 8-nitroquinoline are generated as the mixture of products, so that there is no major and minor, rather both are almost equal quantity of the products are generated at 5th and 8th positions. Sulfonation is accorded by treating this quinoline with sulfur trioxide at the temperature of 90 degrees centigrade, so that 8 quinoline 8 sulfonic acid will be generated if we are rising temperature less than 250 degrees centigrade. So that sulfonation will be carried at the position number 6. This is a peculiarity. This is said to be what as a kind of exception, we can say. 6th position may not substitute the electrophile, but it is the kind of elevated temperature, so that exceptional drastic conditions are operated, so that 6th substitution may possible. But initial substitution will takes place as expected, consideration only at the 8th position it is supposed to be bonded. Halogenation to be performed on this quinoline molecule, bromine dissolving in AlCl3. It is said to be Friedel-Crafts bromination itself, and bromo will giving rise to a mixture of two products. One is at the fifth position and the eighth position bromo substitution as well, so that 5 bromo and 8 bromo quinoline are generated upon this bromination reaction. Sulfonation giving rise, nitration giving rise to 5 and 8 nitroquinoline as the mixture of two products, and bromination again, both the probabilities we have 5th and 8th position respectively. Sulfonation will be carried over Sulfonation is carried over the position 5 and 8 respectively, so that all are expected electrophilic substitution reactions only, so that we got the mixture of two products upon this electrophilic substitution reactions of quinoline molecule. Let me perform the Friedel-Crafts acylation and alkylation together upon this quinoline molecule. Whenever quinoline is supposed to be treated with this acylating agent in the presence of AlCl3, if we are blocking this 8th position with methoxy, obviously this acylation will be accomplished at the position number 5 only, because instead of mixture of products, already we blocked the position number 8. That's the reason why only one probability we have in order to achieve this acylation over the position number 5. Oxidation is complete in the presence of potassium permanganate, being it is a strong oxidizing agent. The entire benzene ring will be totally oxidized, giving rise to quinoline dicarboxylic acid, which is called pyridine dicarboxylic acid, which is called a quinolinic acid. This is supposed to be decarboxylated, giving rise to the nicotinic acid, which is called niacin. It's an important application of this quinoline, which is said to be what? Vitamin B3. Vitamin B3 is a kind of B complex vitamin which used to avoid the disease called pellagra. So this is a kind of vitamin very essential for the healthy survival of living organisms. Reduction of quinoline is also accomplished whenever quinoline is supposed to be treated with the platinum and hydrogen mixture together and treated at room temperature in the solvent media methanol. Entire heterocyclic ring will be totally reduced, giving rise to 1, 2, 3, 4 tetrahydroquinoline as the product, right? So if lithium aluminum hydride is the case, is the strong reducing agent operated, there are two probabilities. One is a dihydro and other is tetrahydro. Both the products will be obtained as a mixture of two. But platinum hydrogen giving rise to tetrahydrogenated product. Lithium aluminum hydrate, there are two probabilities, dihydro and tetrahydro together, they are generated as a reduced product. So starting from quinoline. Let me go for this vitamin B3. Just now we gone through that one oxidation process. Wherever this quinoline is supposed to be oxidized in the presence of potassium permanganate, giving rise to quinonoic acid, which is decarboxylated further, giving rise to nicotinic acid, which is chemically known as nicotinic acid and familiar as vitamin B3. Vitamin B3 is deficiency vitamin B3 is inducing the disease called pellagra. That is a kind of swelling of the skin, and that is a kind of infections whichever generated upon the skin, and entire body will be adversely affected by this kind of disease, so that vitamin B3 is more efficient in order to eradicate the disease called pellagra. Nucleophilic substitutions are also performed by this quinoline molecule. Whenever the chlorosubstituted molecule of quinoline, 4-chloroquinoline was taken and sodium methoxide strong base is applied over there in methanol solvent, giving rise to methoxy over this position number 4, methoxyquinoline as the final product. Same 4-chloroquinoline to be treated with the sodium nitrile, giving rise to 4-cyanoquinoline as the final product. This is the way nucleophilic substitution is also possible upon the quinoline molecule. Now, let me discuss about the applications of quinoline molecule. As we already aware that so many potential drugs already generated, and much more research is going on in the laboratories in order to fabricate the new kind of pharmacological entities starting from these quinoline, but already existing, already published, already proven drugs are taken in the market trade. These effective curative medications are to be discussed in this session. So here the pharmaceutical application part is taken into the consideration in this. Quinine and chloroquine together are said to be effective antibiotic agents, and this quinine is having quinoline molecule with this piperidine, and chloroquine is indicated by introduction of chloromoiety over this quinoline molecule, together working like effective anti-malarial agent. Mosquito-induced disease, it will be mosquito-mediated, not induced, mosquito-mediated disease, it will be. Several antibiotics and inflammatory agents also generated starting from this quinoline, and these are effective anti-malarial drugs. Ciprofloxacin is the kind of antibiotic we already gone through, and this is the kind of skeleton which is indicated where quinoline is taken as the core moiety, and this is a nitrogen containing diaza substitute diaza 6-member ring system is there, and the cyclopropyl ring is located upon the nitrogen as the alkylation, and this is effective medication with this fluoro combination for this kind of running nose and a kind of respiratory cold and cough conditions effectively curated, and the disease viral infection called anthrax and plague, such kind of dreary diseases, chronic diseases also effectively curated by means of the drug called ciprofloxacin. It is effective antibiotic able to kill most of the bacterial infections. Pharmaceutical applications of the quinoline, here another drug is provided called pitavastatin. Pitavastatin is taken over there, and this pitavastatin is also effective pharmacophore and taken, and that is effective for the cholesterol lowering agent. Cholesterol lowering agent is nothing but whenever we are taking the blood samples and tested for the lipid level, lipid profile, cholesterol content in the blood, that is very essential in order to go for the sustainable pumping of that blood. If cholesterol level increases, what happens? That may induce the clots in the blood pumping, and the blood pumping will becomes difficult, and that may causes the problem to the heart functioning, right? This is the reason why the kind of drug like pitavastatin is able to lower that cholesterol level in the blood, so that blood clots get mitigated. So cardiovascular diseases may not be observed. The patient who are consuming the pitavastatin kind of drugs, which is composed by this quinoline moiety. And we are having anti-cancer agent, that is a topotecan. Topotecan is also made by what kind of moiety? Here you can locate this quinoline, and we are having the kind of fused system. So many heterocyclic ring systems are also taken in the part of this one, and it is more effective anti-cancer kind of medication. So chemotherapy is the kind of condition we can apply in order to eradicate the cancer. In that regard, this kind of topotecan is the drug which used to curate that cancer-dready disease. And another pharmaceutical application pertaining to quinoline will be debucoin. Debucoin will be there. The debucoin is having a kind of a local anesthesia agent. Local anesthesia is nothing but the kind of drug which able to pass the activity of peripheral nervous system. Peripheral nervous system activities can be some time passed, so that unconsciousness induced at a particular position wherever required. In the local anesthesia, especially required for the minor surgeries, whenever the people are suffering with the minor injuries or else a minor surgeries, if we require that condition, local anesthesia can be applied. Local anesthesia, when applied on the patient, that may pass the activity of peripheral nervous system, so that give the pain tendency may not be absorbed by the patient. And let me introduce another drug called bedaquiline. Bedaquiline is the kind of anti-tubercular drug. It will be where quinoline is taken as the potential pharmacophore. It will be, and tuberculosis is the disease caused by the microbial infection, bacterial infection in specific, so that lung damage is possible. A kind of cough. That infectious lungs may induce the continuous cough to the patient, and that irritation tendency is also induced, that may cause dreary conditions to the patient whenever that is not properly medicated, not properly diagnosed, so that it is very essential to go for the diagnosis and followed by effective medication at early stage only, so that we can help to survive the people who are suffering with this kind of tubercular disease. And bedaquiline is effective quinoline based anti-tubercular agent. Let me introduce another segment called material science applications of this quinoline. It works like a dyes and pigments, the kind of medicine which is that kind of chemical auxiliary which introduced as a dye and pigment will be erythrocin. Erythrocin is the kind of pink color pigment, purple color you can clearly notice. And here is a kind of uh, uh, quinoline based nucleus is accorded for the system. And let me introduce this herbicide and insecticide pertaining to this quinoline will be a quinoline mite is located over there, and that quinoline is having chloro functionality over there, and ether linkage is located, and ester is provided over there. And here it is the insecticide. The compound is said to be proven insecticide compound, and another the same compound will be converted into final one that is most effective insecticide. It will be that is flumetoquine. Flumetoquine is composed by the quinoline with the methyl functionality over the position 3 and 7, and ethyl functionality over the position 2. And here we have the kind of diether ketone, and here is the ether linkage, and here trifluoro acid trifluoro-C double bond CF3. CF3 is nothing but trifluoromethyl ether. It will be. It could be a methoxy actually. It could be methoxy. Instead, we are having 3 hydrogens replacement with the fluoro, so that it is called trifluoromethoxy. It is said to be trifluoromethoxy. So this is the kind of functionalities located at the position number 7. This is having potential insecticidal activity, which is called a flumetoquine. Flumetoquine is a kind of a quinoline-based auxiliary with the insecticidal function. Apart from that, there are additional advantageous applications pertaining to this quinoline will be it works like a catalyst. It works like a solvent as well, being it is an organic compound, so that organic works like an organic solvent to dissolve so many compounds within. That's the reason why catalytic and solvent-based applications are also the characteristic for this quinoline molecule. By this, we successfully accomplished the entire session pertaining to this quinoline, and so many aspects are taken into the consideration, and authentic websites were considered. They got the material got tracked from those authentic websites, and AI powered session. It will be hopefully the people enjoyed the session and got much informative research oriented concept, and academic purview oriented concept, career oriented concept. Academicians, those who are in the field of this kind of track, this kind of session will be very much effective in order to observe the aspirants who are serious about the entrance exams and competitive exams as well. This kind of session will be most interesting and informative as well. And hopefully everybody enjoyed the session, and the session conducted by Dr. Kavita Kottireddy Kota. I'm an academician and researcher. The entire content and the series of sessions pertaining to heterocyclic compounds and natural products and so many alkaloid, terpenoid, so many topics were already recorded earlier, and all available at the channel World of Competitive Chemistry. And I'm requesting all the people to subscribe the channel and share with the aspirants who are really in this exact track, the scholars and who are the scientists in the field and who are working upon this kind of research. So this will be very essential. The kind of session will be very essential. So thank you very much for your patient listening. Thank you, one and all.